All right, so our next unit kind of has a mix of, I don't know, about 4 or 5 different topics, really. So the first thing we'll work with from this unit is parallel and perpendicular lines. So let's take these two lines here. Do these lines intersect? Yes. So if each of these lines kept going, my line's not perfectly straight, but we get the idea. They would intersect, okay? So this red line would be that y equals negative 1/3 x plus 4. Blue line, I don't have blue right there, so let's go there. We got y equals negative 1/2 x plus 2. Well, those are lines that would intersect, okay? So if we go to the next one, do those lines intersect? No. So what we have here, the one got shifted up a little bit. Let's pretend that goes to the 5, okay? So we got y equals negative 1/2 x. Like I said, we'll pretend that one went through the 5. I think I accidentally shifted it up a little bit. Plus 5. For the blue line, we got y equals negative 1/2 x plus 2. So these two don't intersect. What can you tell me about those two equations? They have the same slope. So if we have parallel lines are going to have the same slope. Okay? So if we got parallel lines, have the same, and same means exactly the same, signs and everything. Okay? Obviously, these lines, the way they intersect, though, if I turn it, it's a little easier to see. They are perpendicular. That means they intersect at a 90-degree angle. When it's tilted, that's not always the easiest to tell for sure, but these are two perpendicular lines. For my red line, I got y equals negative 1/2 x, and it's plus 1 this time. For my blue line, I got y equals 2x plus 1. The plus 1 is the same on both of them. That's not what makes it perpendicular. If I move it over here, they don't both go through 1 anymore. They're still perpendicular, right? What makes them positive 2? 4 perpendicular lines what an inverse reciprocal means, all that means is you flip it, change the sign. So the one had a slope of 2. If we pretend 2 is 2 over 1, right? If I flip it and change the sign, the perpendicular line has a. All right, so if I had a slope of 2/3, the perpendicular line would be negative 3/2. If we start off with a negative, like if I had negative 4, when I flip that, that's 1 over 4, and it becomes positive. Those would be perpendicular. On that. So if they're parallel, they have the same slope. If they're perpendicular, you flip it and you change the sign. So right here, we are looking for two perpendicular lines. So here's the slopes. I got -4, +4. I got 1/5, 5. I got -2 and 1/2. I got 2/3 and 2/3. So, who thinks they can tell me which one is perfect? B is the one that's correct. So, B is our perpendicular lines. Parallel. Parallel. So, these two here, -4, they're just like two regular lines that intersect. Same, they're going to intersect. We have -2. We flip that. That becomes 1/2. Change the sign. It's the positive 1/2. D, like we said, is parallel, where they're the same. Okay? So far, not so bad, right? All right, so let's actually do some math then with it. Sydney? No. Who's got the slope for that equation? Two. So, to find the uniform equation, that means we do the opposite of A over A is 2, so the opposite of that is -2. B, we got -y, so that's a -1. A negative over a negative makes that a +2. Okay? We don't need to use that anymore. So go ahead and find the. So I've got the equation right here. We can tell me what the slope is. Negative. That is slope. round instead of y equals, it's so the slope for that equation is -1. If the slope equation we don't use mx. So I do y minus mx. I plug in my value. I got 1.5 minus 1.5. So that's a y step 5. So y equals x plus 5. Because remember, one equations, that sort of thing.